Good afternoon, engineer. On this occasion, you are going to tell to you about the relationships between classes. Integrants Brian Almeida, Joseph Chihuano, Kevin Guano Luisa, and Pedro Chumaña. Definition: in object-oriented programming, class relationship refer to the way classes interact with each other to model the behavior of a system. These relationships are fundamental to building modular and structured software. Most common relationship between classes. Association represents of connection between two classes where on classes refer to the other. It can be a simple association, bidirectional, or hey multiples on to many to many. Example: a student class can be association with a course class. Aggregation in this specific form of association that indicates a Goldberg relationship with a class is composed of other class but the classes can exist independently. Example: a class library can have aggregation of the class book. Dependence indicates that one class uses another class butter is not directional structure relationship. The standard class client depends on the class used provided at some point in this implementation. Example: a class invoices can depend on the class customer.
Hello everyone, my name is Brian Almeida. I'm presenting Associations between Classes. Associations between classes. In object-oriented programming in Java, the associations between classes refers to the relationships that exist between two or more classes. These associations can be of various types and are established by creating instance of one class in another, or by interactions between objects of different classes. Here are some common types of association. Importance of class associations. Tenemos. Number one, reality modeling. Uh, in object-oriented programming, to seeks to model the real world through objects and their interactions. The associations between classes allow representing the relationships uh, between the elements of the problem domain in a more accurate way. Number two, code reuse. By designing classes in a modular fashion and establishing appropriate associations, code reuse is facilitated. Will designed class can be used in different parts of a program or even in different projects. Types of associations. Associations by compositions in a type of associations. One class composite contains another class part. The part cannot exist without the composite class. For example, a car as engine. If the car is destroyed, the engine is also destroyed. Number two, associations by aggregations. Similar to compositions, but in this case, the part can exist independently of the composite class. For example, a department has professors. If the department is dissolved, the professor still exists. Types of association clash. Dependently associations. One class depends on another if it used as object of the class at a parameter local variable are returned. There is no strong and lasting connections between classes. That's all for today. Thanks for your attention.
I am going to talk about relationships between classes in databases. In databases, relationships between classes refer to how entities connect to each other. Common relationships are one-to-one, one-to-many, and many-to-many. For example, if you have a student table and course table, the relationship might be that a student can be enrolled in multiple courses, one-to-many, and a course can have multiple students enrolled. The relationships are essential to design efficient and well-structured databases.
The solid principles in oriented objects programming. Overview of solid principles. SOLID is an acronym representing a set of principles of designing maintainable and scalable software systems. These principles were introduced by Robert C. Martin and are widely adopted in object-oriented programming. Importance of building software. They provide guidelines for creating flexible, understand, and maintainable code, emphasizing the need for robust foundation in object programming design. The solid acronym is Single Responsibility Principle. A. Class should have only one relation to change. O. Open-closed principle (OCP). L. Liskov substitution principle (LSP). Subtitles must be substitutable for their basis types. I. Interface segregation principle (ISP). Clients should not be forced to depend on interfaces they do not use. D. Dependency inversion principle DIP. High-level models should not depend on low-level modes but should depend on abstractions. Single responsibility principle SRP. SRP focus on single responsibility. What is SRP? SRP means a class should have only one job or responsibility, keeps things simple and focused. Example: imagining a class doing both logging and user authentications, breaking SRP. If you change logging, it will mess up authentication and vice versa. Following SRP have separated a classes for logging and authentication. Why does it matter? Makes code easy to understand and maintain. Changes in one part of the code don't mess up other parts. Testing becomes simpler with clear and single-purpose classes. Open-closed principle (OCP) and conclusion. What is LSP? LSP states that objects and superclass should be replaceable with the objects and subclass without affecting corrections of the programs. It ensures that derived class can be used whatever its base class is used. Example illustration. Think of the square and the rectangle, and the geometry application on the square is a type of rectangle, but if changing the height of the square doesn't also change the width, it violates LSP. Adverting to LSP. Subtitles like square should be interchangeable with the base types rectangle with the causing uses. Why does it matter? Why does it matter? Propose your code reliability be maintaining expected behavior when using subclasses. Enables polymorphism, allowing different subclasses to be used interoperability.